Welcome to the second annual Symposium on Water in Israel and the Middle East at Northwestern. The specific theme this year is to explore issues of water resilience and sustainability.
Water is a local issue, water is a regional issue, and water is a global issue.
And what we are seeking is to introduce a methodology that combines social and exact sciences.
The 12 most water-scarce states in the world are located in the MENA.
In Israel, where I live, we have 80 millimeters per year. So this is the amount of water that we get annually. It's not a lot of water, and this amount of water cannot support the transpiration to produce good plants, healthier plants, and plants that produce enough food.
So Israel has managed to fill its portfolio for agricultural and landscape irrigation through water reuse, which is very important.
There's a lot more attention that's being paid in recent years to reusing treated wastewater in the Gulf states, and that's a good thing, obviously.
And when you work in an energy with an environmental hat on, you're thinking about how can I mitigate, how can I avoid the risk of climate change. When you work on water, you have given up. You're saying those forces are beyond your control. How could I adapt? How can I manage it to minimize the impacts?
If you look at the contribution to the water shortages in the region, 20% is driven by climate change. 80% is population growth.
I do think philosophers can help by continuing to lay out or to put forward different conceptions of justice and fairness.
Gulf states can mitigate security threats by improving social and environmental resilience in their midst.
Would desalination provide sufficient capacity of reliable water sources to promote cooperation between Israel and its neighbors?
It reflects a heavy dependence of the Gulf states on water from desalination plants.
You're removing the water from the salt. That water, if it's seawater, is 3% salt and it's 97% water. So we're taking a mixture and we're taking the 97% out of the 3%. That's part of the reason why it's high energy. I'm going to take the salt out of the water. I'm not going to try to take the water out of the salt. I'm not going to use pressure. I'm going to use electricity. It's a different way to think about the technology with a similar sort of goal. How do we provide clean water sustainably and economically?
So always when people tell me, oh, desalination is very expensive, I always ask, relative to what? And they say it's an energy hog. And I say, so is your refrigerator.
Our challenge is to produce as much as food, fiber, and biofuel as possible, and using and affecting as little water as possible. We want more crop per drop of water.
First, we can expect by 2050 that there's going to be 50% increase in demand for additional water supplies, and unmet demand will increase by 370% in the region.
Because even if the concept of truth is under attack, as we in this room all know, water scarcity is not a fiction.
So we're looking at innovation that can really integrate new methods with old methods and really coordinate in a much better way to address all of the potential concerns with water, right? To greatly expand the resource base and deliver resources where they're needed.